Good day, everyone. Today, I'm going to discuss derivatives, but before that, let me share to you this quote. Good mathematics is not about how many answers you know. It is about how you behave when you don't know. Let's click the play button and let's start. So today, I'm going to discuss the continuation of the differentiation rules. Again, we have the following differentiation rules. Constant rule. This states that the derivative of a constant function is 0. Power rule. This states that the derivative of a function is done by multiplying the exponent and the coefficient of the variable, then subtracting 1 from the given exponent. Sum rule states that the derivative of the function is the sum of the derivatives. Difference rule states that the derivative of the function is the difference of the derivatives. Product rule states that the derivative of a given function is done by multiplying the first function to the derivative of the second function added to the product of the second function times the derivative of the first function. And today, I'm going to discuss the next differentiation rule, which is quotient rule. Now, quotient rule states that if a function is defined by f of x is equals to h of x over g of x, then its derivative is f prime of x, which is equals to g of x times h prime of x minus h of x times g prime of x all over g of x quantity squared. Now, let's have the following examples. Suppose our function is f of x, which is equals to x plus 1 all over x minus 2. Now, in doing quotient rule, first is we have to identify h of x, g of x, h prime of x, and g prime of x. So, in the given function, h of x is the numerator, which is x plus 1, and its derivative is 1. On the other hand, we have g of x, the denominator, which is x minus 2, and its derivative is also 1. Now, since we have identified the four functions, next is to use the formula and substitute the corresponding values. So we have f prime of x is equals to, or g of x is x minus 2, times our h prime of x is 1, minus our h of x is x plus 1, times our g prime of x, which is 1, all over g of x is x minus 2, then quantity squared. So take note, in using quotient rule, always start at the denominator. So always start at g of x, then h of x, the numerator. Okay, let's continue. So simplifying the numerator, we have x minus 2 times 1. That will give us to f prime of x, which is equals to x minus 2. Then minus, we have x plus 1 times 1. The result is x plus 1 all over the quantity of x minus 2 squared. Now, as you can see, I am using a parenthesis after the minus symbol because that indicates that the terms that you're going to subtract from x minus 2 is x plus 1. So that's why you have to enclose it with a parenthesis. Now, let's proceed. So we have f prime of x is equals to x minus 2. Now, the next step is to distribute the minus sign to the terms inside the parenthesis. So it will become minus x minus 1 all over the quantity of x minus 2 squared. Then, simplifying the numerator, we can cancel out x. And what is left is f prime of x, which is equals to negative 3 all over the quantity of x minus 2 squared. So this is the derivative of the given function x plus 1 over x minus 2. Let's have another example. Suppose our given function is 2x minus 3 all over 2 minus x squared. So same process, we will identify h of x and its derivative, g of x and its derivative. So we have our h of x, the numerator, that's 2x minus 3. And its derivative is 2. Next is the denominator, which is our g of x, and that is 2 minus x squared. Then its derivative is negative 2x. Next is to use the formula, substituting the values. So we have f prime of x, which is equals to our g of x, 2 minus x squared, times h prime of x, which is 2, minus our h of x is 2x minus 3, times g prime of x, which is negative 2x. All over, our g of x is 2 minus x squared, then quantity squared. Okay, simplifying the numerator, multiplying 2 minus x squared and 2, that will give you a result of 4 minus 2x squared. Then minus, then multiplying 2x minus 3 and negative 2x, that will give you negative 4x squared plus 6x all over the quantity of 2 minus x squared squared. Again, you have to enclose the terms after the minus sign inside the parentheses. An indication that the terms that you're going to subtract from 4 minus 2x squared is negative 4x squared plus 6x. Then afterwards, you are going to distribute the minus sign to the terms inside the parentheses. So we have f prime of x, which is equals to 4 minus 2x squared. All you have to do is to copy. Then distribute the minus sign. This will become plus 4x squared minus 6x. Then all over the quantity of 2 minus x squared, quantity squared. Now, combining like terms in the numerator, we can combine the terms with the same variable and exponent, which is x squared. So the derivative of the given function 2x minus 3 over 2 minus x squared is 2x squared minus 6x plus 4 all over the quantity of 2 minus x squared, quantity squared. Let's have the third example. F of x is equals to x cubed minus 3 all over 2x minus x squared. So same process, we will identify h of x and its derivative, then g of x and its derivative. So h of x is the numerator, that's 2x cubed minus 3. Its derivative is 6x squared. Then the g of x, which is our denominator, that's 2x minus x squared. Then its derivative is 2 minus 2x. So substituting it to the formula, that will give us to f prime of x, which is equals to our g of x, 2x minus x squared, times h prime of x, which is 6x squared, minus h of x, we have 2x cubed minus 3 times our g prime of x, which is 2 minus 2x. All over our g of x, the denominator, we have 2x minus x squared, quantity squared. Now, multiplying the numerator, first we have 2x minus x squared times 6x squared. That will give you a result of 12x cubed minus 6x to the fourth. Then minus, now this time, we are going to multiply two binomials. So in multiplying two binomials, 2x cubed minus 3 times 2 minus 2x, we will be using FOIL method. Then using FOIL method, the result is 4x cubed minus 4x to the fourth plus 6, or minus 6 rather, plus 6x all over the quantity of 2x minus x squared, quantity squared. Again, take note, after the given minus sign in the formula, do not forget to enclose the terms inside the parentheses. Next is to simplify. Distribute the minus sign to the terms inside the parentheses. So we have f prime of x, which is equals to 12x cubed minus 6x to the fourth. All you have to do is to copy. Then distribute the minus sign to the terms inside the parentheses. So that will become minus 4x cubed plus 4x to the fourth plus 6 minus 6x all over the quantity of 2x minus x squared, quantity squared. Then simplifying like terms, we can combine negative 6x to the fourth and 4x to the fourth. And we can also combine 12x cubed minus 4x cubed. So the derivative of the given function is negative 2x to the fourth plus 8x cubed minus 6x plus 6 all over the quantity of 2x minus x squared, quantity squared. Okay, so we already know how to use the different differentiation rules. This time, as promised, we will solve the slope of a tangent line using the derivative or the shortest method. Okay, so suppose the problem is you are tasked to solve for the slope of the line tangent to the function f of x equals to x squared plus 1 at given point 1, 2. Okay, so using derivatives in solving for the slope, all we have to do is to derive the given function. Our given function is f of x, which is equals to x squared plus 1. So what are we going to do is to derive the given function, and it will give a derivative of f prime of x, which is equals to 2x. Then after deriving the function, all you have to do is to use the x value of the given point as the value of our variable x. So in the given point, the x value is 1, so we will be using 1 as the value of the variable x. So it will become f prime of 1, which is equals to 2 times 1. And by that, the slope of the line tangent to the function is 2. Another example, solve for the slope of the line tangent to the function 2x squared plus 3 at the given point 321. So same process, you will identify the given function, and that is 2x squared plus 3. Then you will derive the given function that will give us the derivative of f prime of x, which is equals to 4x. Once we are done with the derivatives, next is to use the x value of the given point and it will serve as the x value of our given function. So in the given point, we have 321 and the x value is 3. So we will be using 3 as the value of the variable x. So that will become f prime of 3, which is equals to 4 times 3. And further simplifications, the correct slope of the line tangent to the function is 12. Another given. Solve for the slope of the line tangent to the function f of x is equals to x to the 5th minus 2x cubed at point -2, -16. Now, the advantage of using derivatives in solving for the slope of the tangent line is that even if the function has a degree of greater than 2, it will still be very easy for us to solve for the slope. Whereas if we will use the other two methods, it is very time consuming because the degree of the given function is not or is no longer 2. So it will really take time for us to simplify. So I would suggest that you should use the concept of derivatives. Okay, so using derivatives or the concept of the derivatives in solving for the slope, identify the function that is x to the 5th minus 2x cubed. Next is to derive the function. Its derivative is f prime of x, which is equals to 5x to the 4th minus 6x squared. Next is to use the x value of the given point that will serve as the x value of our given function. So the x value is -2, so this will become f prime of -2, which is equals to 5 times -2 to the 4th minus 6 times -2 squared. Using PEMDAS rule, the correct slope of the line tangent to the given function is 56. Let's have the last example. Solve for the slope of the line tangent to the function 3x to the 4th plus x squared at the given point -1, 4. So again, the given function is 3x to the 4th plus x squared. Next is to derive. The derivative is f prime of x, which is equals to 12x cubed plus 2x. Then next is to use the x value of the given point as the value of the variable x. So the given point is -1, 4, and the x value is -1. So this will become f prime of -1, which is equals to 12 times -1 cubed plus 2 times -1. Then using PEMDAS rule, the correct slope of the given tangent line tangent to the function is -14. Now, test yourself. To make this interactive, I'm going to give the given or post the given, then pause the video, start answering, then afterwards, you may play the video again to check if your answers are correct. Okay, so derive the following given functions and solve for the slope. Okay, so here are the answers of the following questions. Okay, a round of applause to everyone for getting it right. So that ends my discussion. Next meeting, see you for an activity. Goodbye.